Well, hey, living environment, cool cats and kittens. It's time for another edition of the Daily Bellringer. Let's go. All right. Hey now.
Mr. Kovacs class. It's Mr. Kovacs class.
You might learn a ton.
It's Mr. Kovacs class.
He's interested too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class.
Fun. You got everything down now. You've got, right, you come in, you do the bell ringer, right? And then you know that after the bell ringer, I have usually another assignment, an ed puzzle lesson. You can go ahead and start that while you're waiting for me to get started. And then I'll jump into class and I'll run the activity. Maybe it's notes, maybe it's some other activity, maybe it's something else, but that's pretty good. You're into routine. And I try to make sure that everything is clear, like what our targets for the day are, our objectives, right? Like yesterday, our learning target was how can we explain how life on Earth may have begun? And then I gave you 3 vocabulary words. Good. Those words were amino acids, lipids, and archaea. Those are the 3 vocabulary words I wanted you to get into your vernacular as a result of class yesterday. And so today in Bellringer, it would make sense that I would go back to those words to help you practice getting them into your brains, right? Amino acids are chemicals. They are chemicals that contain nitrogen, as well as carbon, oxygen, and hydrogen. And what makes them important to us is that they are the building blocks of proteins. You put a few amino acids together, you get what's called a peptide. You put more together, you get what's called a polypeptide. And if you have enough amino acids together that it does something, we call that a protein. Amino acids make proteins. I know you've heard of the word protein. It's like one of those essential nutrients, that's found in food. And obviously, your cells need protein. That's one of the reasons why you need to eat protein. All right? So amino acids are the building blocks of protein. That's what you need to know. And we learned in the Miller-Urey experiment, right? The Miller-Urey experiment, this famous experiment, that it was in fact possible for amino acids to form as soon as the early oceans became present on the planet. And if you did yesterday's ed puzzle, you know that the planet has changed over time from snowball Earth to very hot molten Earth to all these different. But nowadays it's been pretty steady with this nice thin atmosphere, and then covered mostly with oceans. And those oceans, of course, were a prime place for the development of chemicals, right? As long as there's an energy supply from the environment, which Miller and Urey said were used electricity, like from thunderstorms, let's say. But we know that the sun provides plenty of energy every day, and there's thermal vents that produce energy, like energy from volcanoes and things. So there's lots of places on the planet where energy could be captured to turn random floating molecules into amino acids. The second vocabulary word I wanted you to know yesterday were the lipids. Lipids are long chains of carbon. They're pretty easy to make, right? Long chains of carbon that are stuck together. And the carbons usually have hydrogen stuck to them. And what we learned about lipids yesterday is that they also were formed in the early atmosphere. But what's weird about lipids is they don't mix with water. They're what we call hydrophobic. They do not mix with water. And they tend to curl up on themselves. They tend to curl up on themselves, making little bubbles, right? So lipids make bubbles. Lipids make bubbles. And then you can imagine that those bubbles might capture inside of them would be water that's filled with other chemicals like amino acids. And so the first proto-life forms were just bubbles of lipids that had inside of them amino acids. Right? The lipids are the fats, the waxes, and the oils. They don't mix with water. They tend to fold up on themselves and make little droplets or bubbles. Lipids. Anyway, so it's not too much far of a stretch to see that once oceans developed on the Earth, you started getting this mass of chemicals, of amino acids, and then lipids. And then sometimes lipids would trap amino acids and trap other chemicals. And eventually the big step was a lipid ball full of chemicals that was then able to copy itself. That was a requirement for life on Earth. And that happened about 3.8 billion years ago, at least as far as we can tell from the fossil record. And so if you think of the first life forms would just be bubbles with stuff on the inside, but what makes them living is that those bubbles could copy themselves. And we called the first living organisms archaea. So that was the third vocabulary word that you needed to know yesterday. Archaea are like the oldest form of life, the simplest form of life. They're basically just bubbles with stuff on the inside of them. And, right, so you have lipid on the outside, it's like this bubble, then trapped inside is this mixture of water plus amino acids and other fatty acids and other chemicals. And what makes it special is that it can copy itself. And archaea still exist on this planet, even today. One thing that's interesting about them is that they don't use oxygen. They don't need oxygen because they developed on the planet at a time before there was any oxygen in the atmosphere. All right, we'll talk more today. Remember 3 vocabulary words that you need: amino acids, lipids, archaea.